Hi there and welcome to this edition of our Flip Learning class. Now today we're going to be looking at the alkali metals, and what we're going to be doing is looking at their some reactions and the properties. So we'll go through our objectives now. Okay, so we're looking at group 1, the alkali metals. Okay, and by the end of this video you should understand these objectives. So we're hopefully going to be looking at the reactions of the alkali metals with water and with oxygen, and then we're going to look at the patterns and properties of the alkali metals as we go down the group. Okay, so if we have a look at the periodic table, we can see here that the groups go group 1, group 2, group 3, group 4, group 5, group 6, group 7, group 8 or group 0. Now we're focusing today on group 1, which is this one here. Now this consists of 6 metals. We've got lithium, sodium, potassium, rubidium, cesium and francium. Now the unique thing about each of these is it has the same number of electrons in its outer shell. So because it's in group 1, that number of electrons is going to be 1. So we can put in our outer shell electron, and we can show it there. So it doesn't matter whether it's cesium, lithium, francium, all of them have that 1 electron in its outer shell. Okay, so we are going to look at some of the reactions with oxygen. Now we can see that I've just got some lithium out of the jar, and we can't actually see the lithium yet. Now the lithium is stored in paraffin. Now what I'm going to do is I'm just going to use this scalpel to cut through the lithium, and it's quite firm, but it's not as firm as you'd expect a metal to be. So when you open it up, you can see there that it's really very shiny. Now that's actually actual lithium that we've got, and you can see if I bring this closer to the camera, you can see as I'm holding it, it's starting to fade and the shininess is going to a grey, and this is because the lithium is reacting with the oxygen in the air, and we're forming lithium oxide. Okay. Now the next one we're doing is we are doing sodium. So again, I'll just get rid of the paraffin. So we've got our lump of sodium here, and I'm going to cut through this. Now I don't have to use the scalpel this time, I can just use the knife, and you can see there, I'll get this up to the camera, it goes very shiny, and you can see already it's starting to tarnish where it's reacting with the oxygen. So the sodium is reacting with the oxygen in the air to make sodium oxide. Now the last one that we're going to do is that we're going to show you is potassium. Okay, so again I'm going to use the knife, and you can see how very easy that is to cut, and then you can see again we get that shiny potassium on the inside, and you can see that very quickly it started to tarnish and it started to react with the oxygen in the air to form that potassium oxide. Okay, so let's review what we've done. We have taken the alkali metal and we've reacted it with the oxygen, and we've made the alkali metal oxide. Now if we delete all this, we can actually work through an example. So if we take one of the examples we've just done, so lithium, Lithium has the symbol Li. We react that with oxygen, which is O2 in the air, and that will give us lithium oxide. Now, because the lithium only gives one electron, the oxygen needs two, so we need two lithium atoms to make that lithium oxide. Okay, now we're going to have a look at the reactions with water. So we've got the three metals here. Now we're just going to put some universal indicator in and give that a mix up. Now you can see, if I hold this white paper behind, that it goes a green colour, and that's because the water is neutral. Now what I'm going to do is I'm going to drop in some lithium to start with. Now we're going to watch the reaction and see what happens. Okay. Now it's not doing a lot, it is fizzing. It's fizzing a bit more. And we can hear that popping, and that's because the gas that's given off is hydrogen. Okay, and then you can see it's fizzing around. And I'm going to wait for that to stop. Okay, now you can see that there is a slight purple shadow over here where the water's turned a bit alkali. Okay, now we'll do the next one, which is sodium. Okay, again we can see the fizzing, and we can test that gas, and you can see that it pops because we've got hydrogen gas given off. I'll just wait for that to finish. Now I will do the last one now, and I may have to move the iPad away. Okay, but you can see it sparks, and we've got a nice purple flame, and that fizzes out really very quickly. Okay, so let's have a look at the first reaction that we did. Now the first one we did, we took lithium and we added that to water. Now what we actually made was lithium hydroxide and hydrogen gas. So let's have a look at the symbol equation. So what we did is we had lithium and we added it to water, which is H2O, and we made lithium hydroxide. So lithium hydroxide is LiOH, and hydrogen gas is H2. Now it's not quite balanced, so what we need to do is we need to put a 2 in front of that and a 2 in front of the lithium there, and a 2 in front of the water as well. Now what I'd like you to have prepared for your next lesson is the 5 reactions for all the alkali metals with water. So the word equation that we've got here and the symbol equation that we have here. Okay, now we're going to look at the reactivity of the alkali metals. Now from the videos that we've seen that lithium reacted and it fizzed around, but it was quite reactive, and then when we did sodium it reacted a lot quicker. In fact, when we put the lit splint, the sodium managed to light itself, whereas the lithium just popped. And the potassium reacted very quickly. We didn't even need the splint to get the flame. Now I'll put a YouTube link to rubidium and cesium onto the web page, so you can have a look at that one, but they are very reactive. So we're going to look at why. Now we'll take lithium at the bottom. Okay, they're the least reactive. Now lithium has two shells because it's in period 2, and in that outer shell it has one electron. Okay, now that electron has an attraction to that nucleus. Okay, now that attraction is there, but also this electron wants to leave. Okay, so it wants to leave to form a lithium ion, which would be a lithium plus ion. Now if we go down and have a look at potassium. Now potassium, again, it has that one electron, in its outer shell, but you can clearly see that the difference in space between them means that it's a lot further away. So the forces of attraction between this one and this one are a lot weaker because of that further distance away. So the outer electron will form a K plus ion very, very quickly. Now I'm just going to delete this stuff here to put on our cesium. Now if we look at cesium, now again, cesium, really very reactive, so let's move that up a bit. And if we put our electron, now even compared to potassium and lithium, the electron here is miles away. So again, it reacts so easily because that electron has very little force keeping it with the nucleus. Okay, so we're going to have a quick look at this table of data here, and this will tell us the properties of the alkali metals. Now, as we look first of all at the melting point, and we start with lithium being 180, and then it goes down and down and down, with cesium having the lowest melting point at 29 degrees C, which for a metal does appear to be very low. Now boiling point, again, we start high, and as we decrease down the group we get lower and lower, so that you can get cesium gas at a very low temperature of 671 degrees. Now if we have a look at density, now if we think that density of 1 is equal to water, now as we go, the general trend as we go down the group is that we get higher, with that one minor anomaly where we get a slight dip when we get to potassium. Okay, so we're going to look at the oxidation of alkali metals. Now when an alkali metal loses that outer electron, it becomes a positive ion. So what actually happens is that we lose this second shell. We lose the second shell and we get this as our electron structure. Now the lithium, okay, loses an electron, and that becomes lithium plus. Okay, now what I'd like you to do is draw the diagram that we have here and the equations for the let's just do the three alkali metals, so lithium, sodium and potassium. Okay, so we'll just have a quick review on what we've done. We've looked at the alkali metals, we've looked at the electron structure and how they all have one electron in their outer shell. We've looked at the reactions with air and how they form the alkali metal oxide. We've looked at the reactions with water where they form the alkali metal hydroxide plus the hydrogen gas. We've looked at the patterns in their properties of the alkali metals, and then we've looked at the oxidation of them as well. I hope you've enjoyed this, and I will see you next time. Bye for now.